September 15, 1944, 2:47 p.m. Willow Run Factory, Ypsilanti, Michigan. The thunderous roar of 10,000 riveting guns echoed through the world's largest aircraft assembly building as another B-24 Liberator bomber rolled off the production line. Rosie Martinez wiped the sweat from her brow and checked the massive production clock hanging from the factory ceiling. 2 minutes and 37 seconds ahead of schedule. She had just completed her section of the fuselage assembly, installing the radio equipment bay and oxygen system lines on bomber number A3074. In 8 hours, her shift would install the same components in 48 more aircraft. By the time she punched out at 11 p.m., 48 four-engine heavy bombers would have emerged from the Willow Run factory, each one ready to carry 10 tons of bombs deep into Nazi Germany. "Martinez," shouted her section supervisor Tom Willis over the industrial cacophony. "Number 83075 coming down the line in 90 seconds. You ready?" Rosie nodded and reached for her pneumatic rivet gun. 90 seconds between aircraft. The same amount of time it took her to walk from the parking lot to the factory entrance. In the time most people needed to tie their shoes. Another heavy bomber capable of leveling a city block would begin taking shape under her skilled hands. The assembly line stretched for over a mile through the cavernous factory building, longer than the Empire State Building was tall. Every 6 minutes, another B-24 Liberator emerged from the final assembly station, its 4 Pratt & Whitney R1830 engines already installed, fuel tanks topped off, machine guns mounted, and bomb bay doors tested. From raw aluminum sheets to combat-ready bomber in less than 18 hours. At Station 47, where Rosie worked, the fuselage sections arrived as precise aluminum frameworks, pre-drilled and fitted with numbered components that could only be installed in one correct sequence. The engineering was so precise that workers with just 3 weeks of training could perform complex assembly operations that would have taken skilled craftsmen months to master before the war. Behind Rosie at Station 46, Maria Gonzalez was installing the electrical harnesses that would power the bomber's defensive turrets. Ahead, at Station 48, Betty Thompson was mounting the radio operator's equipment panel. Each woman had one specific job, repeated every 6 minutes, perfected through thousands of repetitions until the complex became routine. The mathematics of mass production were staggering. Willow Run employed 40,000 workers across 3 shifts, operating 24 hours a day, 7 days a week. The factory consumed 1,500 tons of aluminum, 50 tons of steel, and 30 tons of electrical components every single day. Rail cars lined up outside the building like a freight train stretching to the horizon, each one loaded with the raw materials that would become air power within hours. But Willow Run was just one factory among dozens. Across America, similar scenes played out at Douglas Aircraft in Long Beach, Boeing in Seattle, Consolidated Aircraft in San Diego, North American Aviation in Inglewood. Each facility had been designed from the ground up for maximum production efficiency, using principles pioneered by Henry Ford in automobile manufacturing but refined to unprecedented levels of precision. At 2:48 p.m., exactly on schedule, bomber number 83075 reached Rosie's station. The aluminum fuselage gleamed under the factory's harsh fluorescent lights, already fitted with wing attachment points and landing gear mounts. She had 90 seconds to install 17 electrical connections, mount the radio rack, and connect the oxygen system manifold. 90 seconds to complete work that would have taken a traditional aircraft craftsman an entire afternoon. Rosie's hands moved with practiced efficiency, each motion economical and precise. Connect the primary radio power cable, red wire, to terminal A. Install the backup frequency selector, turn 90 degrees clockwise until seated. Mount the oxygen regulator valve hand tight, plus 1/4 turn with the pneumatic wrench. Every step was numbered, every component color-coded, every tool positioned within arm's reach. At 2:49:27, she slapped the green completion button beside her workstation. Bomber number 83075 lurched forward on its track toward Station 48, where Betty Thompson was already reaching for the first component in her sequence. In the 33 seconds remaining in her 6-minute cycle, Rosie checked her tools, reviewed the specification sheet for the next aircraft, and mentally prepared to do it all again. What Rosie Martinez couldn't know as she prepared for bomber number 83076 to arrive at her station was that her individual productivity in this single shift would exceed the total aircraft output of entire German factory. While she and her colleagues would complete 48 heavy bombers in 8 hours, the Messerschmitt factory at Augsburg would struggle to produce 3 fighters in the same period. The industrial might of America, channeled through the revolutionary efficiency of assembly line production, was creating air power at a rate that defied comprehension. Every 6 minutes, another bomber rolled off the Willow Run line. Every 5 minutes, somewhere in America, another combat aircraft of some type emerged from a factory and began its journey toward the war zones of Europe and the Pacific. The question wasn't whether American industry could produce enough aircraft to win the war. The question was whether the rest of the world could survive the avalanche of air power now pouring from American factories at a rate of 1 plane every 5 minutes, 24 hours a day, every day of the September 15, 1944. 6:15 p.m. Office of Aircraft Production Statistics, Washington, D.C. Colonel Robert Patterson stared at the production reports spread across his mahogany desk. The numbers so extraordinary that he had ordered his staff to verify them 3 times. The weekly summary from American aircraft manufacturers read like something from a fever dream of industrial capacity. "Sir," said his aide, Lieutenant Sarah Chen, "the Willow Run figures are confirmed. They produced 40 32 B-24 Liberators this week. That's more 4-engine bombers than the entire German aircraft industry produced of all types combined." Patterson picked up his red pen and circled the Willow Run numbers. 432 heavy bombers in 7 days. The same factory that 18 months earlier had been an empty field in Michigan was now single-handedly outproducing the combined aircraft manufacturing capacity of the Third Reich. But Willow Run was just the beginning of the story. Patterson's weekly report showed production figures that redefined industrial warfare. Boeing's Seattle plant had delivered 89 B-17 Flying Fortresses. Douglas in Long Beach had completed 156 transport aircraft. North American Aviation had rolled out 312 P-51 Mustang fighters from their Inglewood facility alone. The mathematics were staggering. In the single week ending September 15, 1944, American factories had produced 2,654 military aircraft of all types. That was 37 to the 9 planes per day, 15 per hour. 1 every 4 minutes around the clock. By contrast, German intelligence estimates suggested that all German aircraft factories combined were producing approximately 800 planes per month. Less than what America built in 10 days. Lieutenant Patterson said, reaching for the comparison charts. "Show me the German production estimates again." Chen placed a classified intelligence summary on his desk. The document, compiled from reconnaissance photos, captured German documents and prisoner interrogations, painted a picture of an aircraft industry struggling under impossible constraints. The Messerschmitt factory at Regensburg, Germany's largest fighter production facility, was completing approximately 12 Bf-109s per day when operating at full capacity. But air raids, material shortages, and labor problems meant the plant rarely operated at full capacity. The weekly average was closer to 60 aircraft, less than Willow Run produced in 90 minutes. The Focke-Wulf plant at Bremen, responsible for producing the feared FW-190 fighter, managed 8 aircraft per day under optimal conditions. The Junkers bomber factory at Dessau struggled to complete 1 Ju-88 every 2 days. The Heinkel works at Rostock had been reduced to producing wooden training aircraft because aluminum was unavailable for combat planes. Patterson pulled out his slide rule and began calculating ratios. The Willow Run factory alone was producing more than 7 times the total output of Germany's 3 largest aircraft plants combined. If you included all American aircraft production, the United States was building approximately 20 aircraft for every 1 produced in Germany. But raw numbers told only part of the story. The quality and sophistication of American production was equally revolutionary. At Douglas Aircraft in El Segundo, California, the AD-1 Skyraider attack plane was being built with prefabricated components so precisely manufactured that parts from different factories could be interchanged without modification. Quality control standards were so rigid that the rejection rate for major components was less than zero. Compare that to German production, where chronic material shortages forced manufacturers to accept increasingly inferior components. Intelligence reports describe German aircraft factories using wood where aluminum was specified, fabricating electrical systems with copper-clad steel wire instead of pure copper, and mounting engines that failed quality standards simply because no alternatives were available. At 6:30 p.m., Patterson's secretary brought him the latest flash report from the West Coast. Sir Douglas just called in their daily numbers. They're running ahead of schedule again. Patterson read the telegram and shook his head in amazement. The Douglas plant in Long Beach had produced 47 transport aircraft in the past 24 hours, 47 planes in one day from a single factory. That was more than some German aircraft companies produced in an entire month. The strategic implications were overwhelming. Every month, American factories were adding approximately 9,000 new military aircraft to the war effort. Even accounting for combat losses, training accidents, and aircraft retired from service, the United States was accumulating air power at a rate that made German production irrelevant. By September 1944, American industry had produced over 250,000 military aircraft since Pearl Harbor. Germany, despite having started aircraft production years earlier, and despite having the technological expertise of companies like Messerschmitt and Focke-Wulf, had managed to build approximately 90,000 aircraft over the same period. But the production gap was widening every month. American factories were hitting their stride just as German production was beginning to collapse under the weight of bombing, material shortages, and labor problems. The latest intelligence estimates suggested German aircraft production was actually declining, while American output continued to climb toward theoretical maximums. Patterson reached for his secure telephone and dialed the Pentagon. When General Arnold's aide answered, Patterson didn't waste time with pleasantries. "Tell the general that American aircraft production this week exceeded our most optimistic projections by 18. We're not just outproducing the Germans, we're burying them under an avalanche of air power they can't possibly match." As Patterson hung up the phone, he looked again at the production charts spread across his desk. The numbers represented more than industrial capacity, they represented the quantification of victory. American workers like Rosie Martinez, working their 8-hour shifts in factories across the nation, were quite literally building America's way to victory. One aircraft every 5 minutes. The war's outcome was being decided not by the tactics of aerial combat or the strategies of air marshals, but by the relentless mathematics of mass production. And those mathematics showed that American industry had achieved something unprecedented in the history of warfare: the ability to produce military equipment faster than the enemy could destroy it. March 12, 1943. Ford Motor Company Engineering Department, Dearborn, Michigan. Charles Sorensen stood before a detailed blueprint of the B-24 Liberator bomber, his experienced eyes analyzing every rivet, wire, and structural component with the cold calculation of a production engineer. As Henry Ford's right-hand man and the architect of automotive mass production, Sorensen had been tasked with the impossible: transform the construction of a complex 4-engine bomber from a craft industry into an assembly line operation. "Gentlemen," Sorensen told the assembled team of Ford engineers and Consolidated Aircraft designers, "what you see here is not an airplane. It's 10,000 individual parts that happen to fly when properly assembled. Our job is to figure out how to put those parts together faster than anyone has ever imagined possible." Traditional aircraft manufacturing in 1943 resembled medieval craftsmanship more than modern industry. At Consolidated's San Diego plant, skilled mechanics worked in teams of 8 to 12 men, hand-fitting components, custom drilling holes, and individually shaping metal pieces to match their neighbors. A single B-24 bomber required approximately 18,000 man-hours to complete, with experienced craftsmen spending days on operations that seemed to defy automation. But Sorensen had revolutionized automobile production by breaking complex assembly into simple, repetitive operations. Where automotive craftsmen had once built entire cars from start to finish, Ford's assembly line workers performed one specific task hundreds of times per day. The result had been a tenfold increase in productivity and a dramatic reduction in the skill level required for each operation. "Look at this wing assembly junction," Sorensen said, pointing to a complex intersection where 4 structural members met. "Consolidated's people drill and ream these holes by hand, each one slightly different, each one requiring individual fitting. We're going to pre-drill every hole to precise tolerances using jigs and fixtures. Workers will simply install pre-fitted bolts in pre-positioned holes." The revolution began with precision tooling. Ford's engineers designed massive jigs, metal frameworks that held aircraft components in exact positions while workers performed their operations. These jigs were so precise that parts manufactured in Detroit could be shipped to California and installed without modification. The era of hand fitting and custom adjustment was ending. At Station 23 in the planned Willow Run assembly line, installing the bomber's electrical system had been redesigned from a 2-day operation requiring master electricians into a 12-minute task that could be performed by workers with 3 weeks of training. Every wire was pre-cut to exact length, every connection was color-coded, and every installation point was marked with clear numerical sequences. "Time and motion studies," explained Harold Youngren, Ford's chief industrial engineer, as he demonstrated the new electrical installation procedure. "We filmed master craftsmen performing each operation, then analyzed every movement to eliminate wasted motion. The result is a 94% reduction in assembly time with improved quality and reliability." The transformation extended beyond simple efficiency. Ford's engineers had redesigned the aircraft itself to facilitate mass production. Where Consolidated's original B-24 design required skilled workers to hand-shape metal fairings and custom-fit access panels, Ford's version used standardized components that could be manufactured on progressive dies and assembled without modification. Interchangeability. Sorensen emphasized during a production meeting, "Every component must be identical to every other component of the same part number. If we build 10,000 rudders, any rudder must fit any aircraft. No exceptions, no custom fitting, no individual adjustment." This principle required revolutionary precision in manufacturing. Ford invested millions in specialized machine tools capable of holding tolerances measured in thousandths of an inch. Aluminum sheets were cut by massive progressive dies that stamped out identical parts with clockwork regularity. Engine mounts, landing gear attachments, and control surface hinges were manufactured to specifications so precise that assembly workers never needed to modify components. The human element of the transformation was equally dramatic. Traditional aircraft workers were highly skilled craftsmen who served lengthy apprenticeships and took pride in their ability to solve complex assembly problems. Ford's system required workers who could perform simple operations with mindless consistency. Betty Rodriguez had been a seamstress in a Detroit clothing factory before the war. After 3 weeks of training at Willow Run, she was installing wing-to-fuselage attachment bolts with torque specifications accurate to within 5 foot-pounds. Her operation required no decision-making, no problem-solving, no adaptation to unique circumstances. Every bolt was identical, every hole was pre-positioned, every torque setting was marked clearly on her pneumatic wrench. "The beauty of the system," explained production supervisor Frank Bennett, "is that workers become experts at one specific operation rather than generalists trying to master everything. Betty can install those wing bolts faster and more accurately than aircraft mechanics with 20 years of experience. Because she does nothing else." The psychological transformation was equally profound. Traditional craftsmen worked at their own pace, taking pride in solving difficult problems and adapting to unique circumstances. Assembly line workers were required to maintain pace with the moving production line, completing their operations in precisely allocated time windows regardless of individual preferences or circumstances. At 2:15 p.m. on March 12, 1943, the first test run of the Willow Run assembly line began. A bare aluminum fuselage framework was placed on the moving track at Station 1. Every 6 minutes it advanced to the next station where another group of workers performed their specialized operation. When the fuselage reached Station 47, where Rosie Martinez would eventually work, it had been transformed from empty framework to nearly complete aircraft. Charles Sorensen watched the test run with satisfaction. The B-24 bomber, which had required 18,000 man-hours to build using traditional methods, would require less than 4,000 man-hours on the Ford assembly line. More importantly, the skill level required for most operations had been reduced from master craftsman to trainable worker in a matter of weeks. Henry Sorensen told Ford as they watched the aluminum fuselage move steadily down the assembly line, "We've just done to aircraft manufacturing what we did to automobiles 20 years ago. We've made the complex simple, the skilled routine, and the impossible inevitable." The revolution was complete. American aircraft production had been transformed from a craft industry limited by the number of skilled workers into a mass production system limited only by the availability of raw materials and factory space. The result would be an avalanche of air power that would bury Axis resistance under sheer weight of numbers. September 15, 1944, 3:30 p.m., Messerschmitt AG Factory, Augsburg, Germany. Oberingenieur Hans Weber crouched beside the partially assembled Messerschmitt Bf 1009 G14 fighter, examining the wing root junction with the practiced eye of a master craftsman. The aluminum skin panels didn't quite align. A gap of nearly 3 millimeters showed where precision manufacturing should have created a perfect fit. In peacetime, such a discrepancy would have meant scrapping the entire wing assembly. In September 1944, it meant 30 minutes of careful hand-filing to make the parts fit. Franz Weber called to his assistant, "Bring the dead blow hammer and the forming blocks. We'll have to massage this panel into position." The scene playing out in the Messerschmitt factory exemplified the crisis facing German aircraft production. Where American factories relied on precision tooling and interchangeable parts, German manufacturers were increasingly forced to use handcrafting techniques that belonged to an earlier era of aviation. Each aircraft became a unique creation, individually fitted and adjusted by skilled workers whose expertise couldn't be easily replaced. Weber had been building aircraft for Messerschmitt since 1936, when the company's production methods were the envy of the world. German engineering precision, attention to detail, and commitment to quality had created fighters like the Bf 109 that dominated European skies in the early war years. But by 1944, the manufacturing environment had deteriorated beyond recognition. The wing panels Weber was struggling to fit had been manufactured at a dispersed facility near Munich, part of Germany's desperate attempt to scatter aircraft production away from Allied bombing targets. The panels had been shipped by truck convoy, suffering damage and distortion during the journey. The original Augsburg facility, with its precision jigs and climate-controlled assembly areas, had been severely damaged in repeated air raids. Herr Oberingenieur called out Martha Schneider, one of the few remaining experienced workers on the assembly line. "The fuel injection system for aircraft 432 is missing the primary metering valve. The supplier says aluminum is unavailable for non-critical component." Weber sighed and walked over to examine the partially installed engine. The Daimler-Benz DB605 power plant was mounted in its engine bearers, but dozens of small components were missing or had been replaced with substitutes that required extensive modification. Germany's aluminum shortage had become so severe that aircraft manufacturers were competing with ammunition factories, submarine builders, and radar manufacturers for the same limited supply of strategic materials. "Install a steel valve from the spare parts inventory," Weber instructed. "File the mounting tabs to fit and use high-temperature sealant compound on the threads." It was another compromise in a war increasingly defined by compromise. The steel valve would work, but it would add weight to an aircraft already struggling with performance degradation from hundreds of similar substitutions. The contrast with American production methods couldn't have been more stark. Where Rosie Martinez installed pre-fitted components in 90-second cycles, Weber's team spent hours custom-fitting parts that should have been interchangeable. Where American factories operated with clockwork precision, German aircraft assembly had become an exercise in creative problem-solving and skilled improvisation. The root of the crisis lay in Germany's approach to manufacturing, which had always emphasized quality over quantity. German aircraft were precision instruments built by master craftsmen who took pride in their individual expertise. The Messerschmitt factory employed highly skilled Facharbeiter, master workers who had completed lengthy apprenticeships and could perform complex assembly operations from memory. But skilled craftsmen couldn't be mass-produced like aircraft components. As the war progressed, experienced workers were drafted into military service, killed in air raids or transferred to other critical industries. Their replacements were hastily trained workers, foreign laborers with minimal German language skills, and prisoners of war who had little incentive to maintain quality standards. "We used to have 48 master assemblers," Weber told his production manager Heinrich Braun during their daily crisis meeting. "Now we have 16 masters trying to supervise 60 inexperienced workers. Quality control is becoming impossible." The numbers told the story of German production decline. In early 1943, the Augsburg facility had been completing 18 Bf-109 fighters per day. By September 1944, daily production had fallen to 8 aircraft, and even those required extensive rework before delivery. Meanwhile, defect rates had climbed from less than 2% to over 15%. Meaning that significant numbers of completed aircraft were rejected by Luftwaffe acceptance inspectors. Material shortages compounded every problem. The high-grade aluminum alloys essential for aircraft construction were increasingly unavailable. Steel substitutes added weight and reduced performance. Electrical components were manufactured with copper-clad steel wire instead of pure copper, causing reliability problems in aircraft systems. Engine manufacturers were forced to accept lower-grade materials that reduced power plant performance and service life. "Look at this requisition," Braun said, showing Weber a parts shortage report. "We need 200 kilojoules of aluminum sheet for wing skin pan. The ministry says we can have 50 kilojoules next month, maybe." Meanwhile, the Luftwaffe is demanding increased production quotas. The bombing campaign against German industry had forced aircraft manufacturers to disperse their operations across dozens of smaller facilities, often hidden in forests or underground locations. But dispersed production meant dispersed quality control, inefficient transportation of components, and the loss of specialized tooling that had been destroyed in air raid. The Messerschmitt company now operated 17 different assembly locations across southern Germany, each one struggling with unique problems. The facility near Landsberg was housed in a former salt mine, where humidity and temperature variations wreaked havoc with precision assembly. The forest workshop at Bad Aibling lacked adequate electrical power for precision machinery. The underground facility at Oberammergau was so cramped that workers could barely maneuver large components. At 4:15 p.m., air raid sirens began wailing across Augsburg. Weber and his workers immediately began the familiar routine of covering partially assembled aircraft with protective tarps and moving critical components to reinforced shelters. Production would stop for at least 2 hours while American bombers passed overhead, possibly targeting the synthetic fuel plant 20 kilometers away. "Every day we lose 4 to 6 hours to air raid interruptions," Weber muttered as he helped secure aircraft 4171 under its protective covering. "The Americans build aircraft around the clock while we spend half our time hiding from their bombers." When the all-clear sounded at 6:30 p.m., Weber surveyed his production line with growing despair. 8 partially completed fighters sat in various stages of assembly, each one representing hundreds of hours of skilled labor, each one requiring creative solutions to problems that shouldn't exist in a properly equipped factory. The mathematics of German aircraft production had become an exercise in managing scarcity, where American factories operated with abundance, unlimited aluminum, precision tooling, skilled workers, uninterrupted production schedules. German manufacturers struggled with shortages of everything except determination and ingenuity. As Weber returned to his custom fitting of wing panels, he couldn't know that on the same day at the same hour, American factories were completing aircraft at a rate that made his entire weekly production irrelevant. While his team would struggle to complete 8 fighters in the next 24 hours, American assembly lines would roll out nearly 400 combat aircraft of all types. The industrial war was being lost not through any failure of German engineering skill or worker dedication, but through the remorseless mathematics of mass production competing against craft manufacturing under impossible constraints. May 8, 1945, 11:47 a.m. Tempelhof Airfield, Berlin, Germany. Lieutenant Colonel Don Blakesley walked slowly across the cratered concrete of what had once been Germany's most prestigious military airfield, his boots crunching on fragments of glass and twisted metal. Scattered around the field lay the burned-out hulks of Luftwaffe aircraft. Messerschmitt Panzerondines, Focke-Wulf 90s and Junkers bombers that would never fly again. The irony was not lost on him. 14 months earlier he had led the first American fighters over Berlin, shocking German pilots who believed their capital was beyond the reach of enemy escorts. Now, on the day Germany officially surrendered, he stood on German soil surrounded by the wreckage of an air force that had been buried under an avalanche of American production. Behind him, his crew chief, Master Sergeant Tony Ritchie, was conducting an inventory of captured German aircraft. "Colonel," Ritchie called out, "I count maybe 30 fighters here, and most of them look like they were cannibalized for parts. Hell, we probably built 30 fighters yesterday afternoon at one factory back home." The numbers told the story of industrial warfare carried to its logical conclusion. From December 1941 to May 1945, American factories had produced 224,750 military aircraft. In the same period, German industry had managed to build approximately 120,000 aircraft of all types. The United States had outproduced Germany by nearly 3-to-1 in total numbers, but the real advantage lay in the sustained rate of production. By 1944, American aircraft factories were completing one military aircraft every 20 to 95 seconds around the clock, every day of the year. German production, hobbled by material shortages and bombing damage, had fallen to approximately one aircraft every 45 minutes during daylight hours when factories could operate. The mathematical gap had become a chasm that no amount of German engineering brilliance could bridge. Major Wilhelm Schmidt, a former Luftwaffe pilot now in American custody, stood nearby watching the American officers examine the destroyed aircraft. His own Messerschmitt Panzerondine G-14 sat among the wrecks, its engine removed for spare parts, its wings stripped of usable components. "You want to know why we lost?" Schmidt said to Blakesley in heavily accented English. "It wasn't your tactics or your training, it was your factories. Every time we shot down one of your aircraft, 2 more appeared to replace it. Every time you shot down one of ours, we had to wait weeks for a replacement." Schmidt's observation captured the strategic reality of the air war's final phase. German pilots who survived combat in 1944 and 1945 described facing overwhelming numbers of enemy aircraft that seemed to multiply faster than they could be destroyed. Luftwaffe records showed that by early 1945, German fighters were routinely outnumbered by ratios of 10 or 15 to 1 over their own territory. The Battle of Berlin in April 1945 had illustrated the final collapse of German air power. The Luftwaffe managed to assemble fewer than 100 operational fighters for the defense of their capital city, while Allied air forces deployed over 2,000 combat aircraft in support of the ground offensive. German pilots, many of them flying obsolete aircraft, with critical components missing, faced American and British fighters that represented the latest in aviation technology, built in unlimited quantity. Master Sergeant Ritchie found a maintenance log in one of the German aircraft and brought it to Blakesley. The handwritten entries in precise German script told the story of desperate improvisation. Engine oil pressure low, no replacement pump available. Port wing cannon removed for installation in aircraft 3. When a P-51 Mustang developed mechanical problems, it was typically scrapped and replaced with a new aircraft from the production line. When a German fighter needed repairs, mechanics cannibalized other aircraft to keep a few machines operational. The production statistics that Colonel Patterson had compiled in Washington now seemed almost surreal when viewed from a captured German airfield. Willow Run alone had produced AT-685 B-24 Liberator bombers during the war, more four-engine aircraft than the entire German aircraft industry had built of all types. Boeing had delivered over 12,000 B-17 Flying Fortress. North American Aviation had manufactured more than 15,000 P-51 Mustang fighters. "Look at this," said Captain Jim Howard, Blakesley's intelligence officer, pointing to a German production report found in the airfield's administrative building. The Messerschmitt factory at Augsburg completed 84. North American Aviation built more than that in 3 weeks. The human cost of the production war was equally telling. American aircraft factories had employed millions of workers, many of them women, who entered the workforce for the first time. These workers operated in safe, well-equipped facilities with abundant materials and uninterrupted production schedule. German aircraft workers, by contrast, labored under constant air attack with chronic shortages of materials and tools, often in dispersed facilities that lacked basic amenities. Rosie Martinez, who had installed radio equipment in B-24 bombers at Willow Run, had completed her shift every day knowing that her work contributed directly to victory. Hans Weber, struggling to fit mismatched components in German fighters, had worked each day knowing that his efforts couldn't possibly keep pace with enemy production. As Blakesley walked among the destroyed German aircraft, he reflected on the strategic revolution that American industry had achieved. The concept of winning through sheer volume of production had been proven on a scale unprecedented in human history. German pilots, no matter how skilled or brave, couldn't overcome mathematics that produced 20 enemy aircraft for every one they could build. The final Luftwaffe sortie of the war had occurred 3 days earlier. A single Messerschmitt 26-2 jet fighter that managed to take off from a hidden airstrip near Munich before being shot down by P-1 German aircraft against hundreds of Allied fighters. A perfect metaphor for the production war's outcome. Lieutenant Colonel Blakesley picked up a fragment of aluminum skin from a destroyed Focke-Wulf 90, examining the precise German craftsmanship that had shaped the metal. The workmanship was excellent, the engineering sophisticated, the design innovative, but individual excellence couldn't compete with mass production when the numbers reached the scale that American industry had achieved. At 12:15 p.m., as Blakesley climbed into his jeep for the ride back to his temporary headquarters, Master Sergeant Ritchie made one final observation. "Colonel, you know what's really crazy? Back home they're already starting to shut down the aircraft factory. The war's over, and we've got more planes than we know what to do with." That was the ultimate measure of American industrial victory. Not only had the United States outproduced its enemies by overwhelming margins, but production capacity had been so vast that factories were being closed while still operating at peak efficiency. American industry had literally built its way to victory, creating air power faster than any enemy could destroy it. The revolution that Charles Sorensen had begun at Willow Run, applying Henry Ford's assembly line principles to aircraft manufacturing, had decided the outcome of World War. The mathematical precision of mass production, operating at a scale never before achieved in human history, had buried Axis resistance under an avalanche of American-made aircraft. Workers like Rosie Martinez, repeating their precise operations every 6 minutes for years on end, had quite literally manufactured victory. Their individual contributions, multiplied by millions of repetitions across dozens of factories, had created the overwhelming material superiority that made Allied victory inevitable. The age of industrial warfare had reached its logical conclusion on the cratered runways of Tempelhof Airfield, where the remnants of German air power lay scattered and defeated, overcome not by superior tactics or technology, but by the remorseless arithmetic of American mass production.